We're going to do something a little different this time. We got you for an hour and a half, okay? It's a good time block. And we're going to invite you guys to come into our living room. We're going to let you be a fly on the wall for this NativeScript plugin talk. Okay, we got Nathanael Anderson, probably one of the widely published NativeScript plugin authors. Brad Martin, arguably also. And I've published a few here and there. So we're going to dive into all sorts of things. We got Android specifics, iOS specifics, and we've got a lot of content. So we're going to try to cover it, but we're going to do it in a little different way than you probably have seen before. Theater style and scene.
What is my purpose?
Pass the butter. Thank you.
Dad, I need a ride to work.
Maybe Rick can give you a ride. I'm helping Morty with science.
I'm busy.
Doing what?
Anything else?
What is my purpose?
You pass butter.
Oh my god.
Yeah, welcome to the club, pal.
You know, I love that scene right there. I gotta say, like, robot could have done so much more than just pass the butter. And in fact, there's someone here, Sebastian Whittelick, who's programmed the robots to do way more than just pass the butter with NativeScript. And I don't know if you noticed, but Morty's parents were on that. So it's possible they may have been able to control that robot way more. I think they know the channel. Let's check out the Android channel here. Check.
That's
Okay, thank you. All right, let's check out the Android channel here.
Now take you apart, find out which screw is loose.
Apart, undone, dismantle, dissect, disassemble.
All right.
No, that is the wrong
No, I'm pretty
channel.
sure that's it.
No, that is the wrong channel, Nathan. Hang on 1 second.
You take control of the TV.
Okay, so actually we need to start with, what is a plugin? We have to understand what is a plugin first before we can actually dive into how you would possibly control that robot. You would have to know how to create a plugin with NativeScript, and where else would you get started creating a plugin with NativeScript?
Where would we get started, Brad?
Well, there are many options, but the suggested option would probably be the official plugin seed.
They got a seed for that?
There is a seed for the plugins in NativeScript. Comes with very great scaffolding right out of the box, built-in unit testing, built-in support for CI, and also a great workflow.
Now, hang on. This workflow is something that I kind of am in debate about. Sometimes I kind of like to tweak my plugins. I don't know if I want a seed doing all that for me.
Yeah, well, I understand that. I like to take control of everything as well, but
You're controlling?
Yes, sometimes, So the workflow is very critical. There's many ways you can develop a plugin. You could control everything yourself and move things around from node modules to the app. But with the official plugin seed, everything is handled for you with a few commands. In the source directory of your plugin, if you run npm run plugin tsc watch, it basically kicks off a TypeScript compiler in watch mode. So any changes that happen in the source directory are going to get transferred into the demo app.
Now, this is from the official plugin seed. This is on the NativeScript org.
This is, yes.
Okay.
This is the official seed. I think it's based off some work that you did, actually.
I don't know anything about that.
So I think it might be based off some stuff you did. So it also comes with the demo app. So in the demo app, once you run npm run demo Android or iOS, it's going to add the platform. It's going to build out the application with the plugin. And since TSC Watch is running, any changes are just going to get transferred over.
So you mean the changes I make in my source plugin files are going to get transferred to the demo?
Yes, that is correct.
Okay. All right.
So basically live sync for your plugins. There's many ways you could do that, but this is the official plugin seed approach. Works very well. And so also in plugins, you have to know Android and iOS. And Android is the best, hands down. There's no doubt about it.
Now, somebody tells me you are a specialist in Android.
Well,
is this true?
I don't claim that to be true. I think I just do a lot of trial and error and stumble my way through quite often. So
would you say that's true, Nathaniel?
I don't know. Maybe. So with plugins, there's a lot you have to know about Android if you're going to create a plugin that's going to tie into some native Android, either the APIs using some SDK. You have to know several different things that are related to native Android. And the first, and one of the most critical, is the manifest for the Android platform.
What's the manifest?
Well, the manifest is basically, it describes the structure of your application. It also has the unique name of your application as it gets published. You specify the permissions. Also, you can specify the minimum Android API that you're going to target, as well as the target API for Android. You also can specify drawables, which are basically the app resources, if you're familiar with those in NativeScript.
The drawables, that's a Java thing?
Yes, more or less. It's specifically related to Java and Android.
So since Android Manifest is strictly, this all comes from Java, Android, there's nothing really NativeScript specific about this file.
No. This is pure Android. There's nothing NativeScript so far, but you will definitely want to know how to harness the manifest for your plugin. So also activities, services, and intents are going to end up in the manifest, again, because it describes the structure of anything that your Android app is going to access as it goes forward.
What's what's an activity?
An activity is basically something inside of your app. It's an Android activity. You can think of it as a screen, but I'll get there in just a second. First, I want to actually tell you guys about the manifest and how it relates to the plugin. So in the plugin, basically, in the source directory, you'll have a platforms folder, and this is where you'll target Android and iOS. Anything specific to the native library or SDK that you're going to use, this is where it will go. So
now, what are we looking at, Brad? I see a plugin folder, and there's platforms.
Yes.
What is plugin?
Okay, so plugin, think of that as the source directory here. If this was the official plugin seed, consider that the source of your plugin. Okay. So there is a subdirectory for the platforms, and then also Android and iOS beneath the platforms. And so the manifest goes inside of the Android folder, obviously, since it's related to native Android applications. And right here you'll see I've outlined here a few permissions. As I mentioned previously, this is where permissions go for Android. Any type of permission that your app is going to use, if it needs access to location, the camera, audio, you have to specify those permissions in the manifest so that Android gives you access to those APIs.
Now this internet permission and get accounts, are some of these default?
There are some default ones typically when you create an Android application. These I just grabbed from something I was working on the other day. So it's not anything specific. And then also, as I mentioned, the activities, back to what Nathaniel was saying, if your app is going to harness any activity that might come from a third-party SDK, typically you're going to have to specify that your app uses that activity in the manifest.
So this, I see Facebook in there. This is an example of a Facebook authentication?
Yeah, well, more or less. It is the Facebook activity, which basically is the login activity from the Facebook SDK, again, for Android. So I've specified that here in this plugin, in the manifest. And so when this runs in the demo app for your plugin, it's going to, the CLI is going to create the plugin, and it's going to merge this manifest with the actual manifest in your application. Does that make sense?
It does. Now, the structure of this, you got uses permission at the top, you got activity at the bottom. Does the order matter?
It does not. You could sprinkle it around. There are some node level values as far as how you can specify this tree here, but for the most part, you could have moved permissions below the activity if you wanted.
And the manifest has to be the root node.
Yes.
There's never
Yes.
any node that encompasses these other
That is correct.
points.
That is correct. So back to what Nathaniel was asking about an activity. So what is an activity? An activity, the way Android and Google describe it, is a single focused thing that the user can do. So think of it as one screen in your application. So for example, the Facebook activity, it has one purpose. It is to authenticate against Facebook's SDK and return something to you since you're consuming that SDK. And with NativeScript, the app has one core activity in the Android. It's TNS.Nativescript activity, I believe, something along those lines. There is a second one, which is for errors, but the main driver of your NativeScript app is one Android activity, and your views, so all of your pages in NativeScript, get kind of shoved into that one activity. And so to understand activities, you need to have a decent understanding that an activity in Android has life cycle hooks, basically. So everything from when it's started, when it's launched, when it's paused, stopped, and resumed. So those activities are very crucial when you're working with plugins, because there are some SDKs and third-party libraries that you need to set up event hooks or listeners when one of these activity lifecycle events occur.
So this is a lot of information right here. The Android activity, is it tied to the view in any specific way?
Not necessarily. No, your view. So your view gets put into the activity. Does that make sense to you?
That does.
Okay. So when you create your view in Android, it's added to the activity. I forget the method now, but there's a method on the activity where you put the view into that activity.
So would you say every single NativeScript app out of the box, you said, has the one Android activity?
Yes, well, there's two, but there's one core activity.
Core activity. What do they call that?
The core activity?
Yeah.
It's
Is there a name for it?
NativeScript. NativeScript application.
Yes.
And then
Okay.
error logger.
And the error activity is the activity whenever you crash your NativeScript app. If you've ever done the Android NativeScript, you see that screen pop up, and it shows you the logcat.
Is that coming from NativeScript? Is that NativeScript helping us with the error?
Yes, because
It
that
is.
activity is from the NativeScript application, hooking into the logcat output, basically to show you the stack trace of when you have
So
an error.
this main activity that NativeScript creates, I just want to get, this is something NativeScript gives us to help us build the Android app.
Yes.
It's,
yes.
And otherwise, if we were building an Android app by ourselves, we'd have to create this activity?
Yes.
By
yes.
ourselves?
Yes, you start with an activity when you create an Android application. Typically, it's a blank activity, or you start with one of the templates that Android provides you.
Okay.
It's-
Now back up there. Back up. I'm going to take control of the remote.
Okay.
This you can't, I don't know if we can see this very well, but.
Are you talking about the diagram
Yeah.
over
What's
here?
all this is talking about?
So that is the life cycle for an activity. It is kind of, I probably should have made that better, but there are life cycle events that occur with every activity.
What's like that first one?
I believe that's the start. So it's created and then it's started, and that also hooks into the resume method. So if you, which I'll get into that, how that ties into plugins, again, because you're going to need to know those events occur and how you hook
I would
into
think
them.
these would be pretty important, right? This is queuing when the app starts, and then also queuing when the app goes into the background?
Yes, you can track the life cycle of the activity. In Android, rather than it being considered an application, each screen is typically a activity that you can launch independently. NativeScript does it a little bit differently in that we only have one activity and everything runs inside that activity. And so they expose some of that functionality to us at the JavaScript layer. But in a true Android application, native Java, each activity is like its own little separate world. And so that's basically the difference between the two.
Are there any limitations that you guys know of that being inside of this NativeScript world in that sense and how it is managing the life cycle would invoke, or you still have full control?
You still have full control. The only limitation I can think of is you really can't run two NativeScript apps inside of itself. You can't run the activity a second time from itself, I don't
And
believe.
you'd say
But
that
that's not
if
something you'd
you
want to
were
do anyway.
If you were to create an Android app on your own, would that be something that's beneficial to run two activities within itself?
And yeah, in a normal Android application, you do run multiple activities. An activity transfers control to another activity, which then transfers control to another activity. And so each screen typically is its own activity. Where NativeScript, we do each screen as a separate, piece of JavaScript code that you just load in and use navigate to in normal plain NativeScript. And
So I'm just going to give an example. If I was logging into Facebook or Google and it launches some off screen, that's a separate activity?
correct.
Does it have to be a separate activity?
It typically is because that's the way Android was written, is to each thing is a separate activity. And that's the reason why when you're integrating plugins into a NativeScript, you have to understand some of this activity stuff because NativeScript does not do activities the same way. Everything runs in one activity. And so you have to sometimes say, oh, I want to call this activity so that it pops up their screen, and then that screen, when it's finished, it resumes your activity. And so you have that life cycle of when your screen finishes, when your screen restarts, and so you can continue your path of code.
So I'm getting super bored with this activity talk.
Yeah, let's move on so I can teach you something else here in regards to how native Android relates to plugins.
Thank you.
And so understanding that the activity has life cycle is important for the plugins. And right here in this example I've got consuming this SDK, or this Android library here, is calling this open activity method, which is basically calling the onStart activity for result method in Android. And the way this library is set up, the important thing to see here is this fourth argument is a number, and it is the request code that relates to that activity. And why that's important to know when you're consuming and tying into the activity results or the application events in NativeScript is NativeScript has the activity result event, which you're going to tie into when you consume that third-party code. And one of the properties that gets returned here is you see the request code, and that number is always, or it should always match up, because that's how you know you're in the correct result event for that method.
Where does that number come from?
You could set it to whatever you want to.
So when you open activity, you're just identifying that activity to call back with that request code.
Yes.
And this is typically seen in some type of third-party integration on Android.
Yes. If it opens up an activity, there's going to be a request code if it has a result that you are trying to get data back to, or back or from when it returns.
Now I see something here that's kind of interesting. App.Android. App is from NativeScript.
It's the application module. Yes.
And Android off of that is, what is that exactly?
It's a property that specifies the Android instance from the application.
The Android instance as in the instance of the app, so the global instance of the app?
I believe so, yes.
Yes, it is the global instance of the application and has access to certain global properties that you might need through your life cycle of your NativeScript application.
Now the event that you're wired into, that's just a static, it's just a convenient accessor. That I assume is some type of string.
Yeah, there's
event.
There's a string value.
Correct.
Activity result, I believe.
Yes, there's activity result. There's about 10 of them that are built into NativeScript. And you can add more if you need to tie into something that's more unique, but there's several of them that are just default.
And those are global Android event names.
Correct.
Because this Android application convenience that comes from NativeScript is just it's a helpful aid.
Yes,
for
very
the
helpful.
event. Okay.
Unless you want to memorize result activity dot whatever, you know.
Okay.
Yeah, it can get pretty messy in a hurry. So
Okay, I'm following.
Okay, so after activities, another thing to know is interfaces. And that's not the UI that we're referring to here. We're talking of...
Is this like a TypeScript interface?
No, not a TypeScript interface either. An interface as in a collection of abstract methods that a class can implement. So this is very common in object-oriented programming. So Java, again, being object-oriented, has the concept of interfaces. And so those abstract methods, you'll see them everywhere on third-party libraries and SDKs that you're going to probably run into when you want to create your Android plugin.
So this concept of an interface is basically, this is from the Java language itself.
Yes, this is, well, not necessarily from Java, but I don't believe. I mean,
In this specific case, it is Java. That's their design behind it is that it is actually coming there. But a lot of languages use interfaces so that you have a standard API that you code against for that thing, and so it can match up your code to the callback basically. Because it's going to call into your code, and so it needs to you have to have those functions available for it to call.
Yes, and that's what I get into here in this code sample. If you look here, this is straight from Java. This is the example from that Facebook login activity that we were looking at. So it's going to set up this callback, and there are 3 different methods that get called here, and those are part of the interface that they expose. Are you following that part?
I kind of am. This decorator thing's confusing me because I'm
Yeah.
an Angular developer and I'm used to these decorators being like functions that add particular enhanced features to a class or something like that. What the heck is @override?
That is a decorator. It's a Java decorator. I actually don't know a whole lot about those. Nathaniel might.
It basically tells the Java, when it compiles it, that this particular function overrides the default function that's there. And interfaces, typically they're empty. You're basically saying, I need this function available. And so then you have to declare that, and you have to tell it you're overriding the base class, because this is actually a class that you get back from them, and then you're overriding their class methods, these 3 in this case, with your own code.
Now, this is just a Java question. If I was in this Java code and I needed to modify it for some reason to work with NativeScript, and I remove that override decorator, what would happen?
Probably crash.
It would crash. You think so?
Yes.
Okay. That's good to know.
The application would crash when you went back from Facebook to here and it tried to call here. It would probably crash because the method would no longer exist.
Okay.
And so, or it wouldn't compile. One or
That
the
sounds
other.
important.
It is important.
In Java.
And as you use that in your plugin for NativeScript, you need to know that you're going to implement those interfaces. And there's only some minor differences typically between the translation. You can see here we've removed the decorator because we're no longer in Java. So basically it's almost identical if you look at this right here. You see the on success, on cancel, and on error. And again, that's straight from the interface that we were looking at in Java.
Can you back up to the interface?
Yeah, you need to see that again. Yeah.
Yeah. Let me see that again. Okay.
There you go.
Success. All right.
On cancel, on error. So there's your 3 methods.
And you were referencing some class there, com.facebook.facebook callback.
Yeah, that is important to know. So you're accessing that Facebook callback class via the namespace com.facebook. You could set this to a variable, some constant if you wanted to.
You could reference it
Yeah, you
somewhere.
could reference it. You don't always have to call directly through the namespace to get there, but that is the class, and then there's the methods. And so here's the comparison from Java to a TypeScript sample. So you can see the decorators are gone, the public declaration on those methods are also gone. But more or less, it's very
It's interesting that there's an object that's passed to the constructor of the callback, and that object has keys and values on it. And that's just, is that NativeScript translating that to the native class?
Yes, that is the way NativeScript does their overrides so they can talk to Java.
Because I see in Java, it's actually constructing the class, but then the inside of it has these properties. So we're basically constructing the same class, but we're actually providing it these overridden methods in the
Correct.
constructor.
Yes,
And
that
it's
is
NativeScript who takes those properties from the constructor and is actually extending it.
correct. It creates a binding between the native Java side and the JavaScript side and links up the names just the way it is. And that way you're programming the way you would normally program a JavaScript thing, and you want to pass in a Java function set or group of functions in your object class.
That's very interesting, and it also sounds critical to know. If you're going to work with Android, are all the classes that you might construct in this way and override, does NativeScript by default take the constructor arguments and extend the class that way?
Yes.
That's pretty typical.
Yes.
Okay.
And so you're following the interface part.
Yeah, I'm getting it a
Talk
little bit.
activities and interfaces.
Ever wonder what we intelligent, independent, adventurous types drink? Celestial Seasonings Herb Tea. They call this one Lemon
I hate your
Zinger.
commercials. How about writing the book?
Celestial Seasonings. Teas more tastefully done.
I can't believe it. Don't you ever quit? I've been away a long time.
Not that smart.
And my roommate's still going strong.
Remusic Roommate Air Freshener with twice the freshening liquid so it freshens air longer than Magic Mushroom.
Long-lasting roommate.
Gonna need to get that for you, Nathaniel. Let me see this now. So there's something that I want to go to a particular channel that I really love. This one I probably watch all the time.
Do we really have to?
I'm sorry, but this is the channel. You just made me watch Android.
Yeah, but iOS, man.
Listen, it's not as bad as you think.
Okay.
It's really not. Actually, Apple has a rich set of development tools. And they're important to know because all these development tools really work with NativeScript out of the box. And in fact, NativeScript wouldn't work at all without these development tools. One in particular, Xcode. It is the de facto IDE for OS X development, iOS, Apple Watch. Basically, anything that you would develop as a software engineer for Apple might go through Xcode.
So you need it.
Definitely need Xcode. And in fact, you couldn't build for iOS without Xcode. Unless you're going to use the new nifty NativeScript Sidekick, which would let you build in the cloud, which is pretty cool. But if you're going to build locally, you're going to have Xcode installed. And the development environment is based on a couple core concepts that are really important to understand. For one, back when Steve Jobs kind of brought around the development environment, it was based around Cocoa. And Cocoa is really kind of it encompasses the whole framework of Objective-C development. And Cocoa Touch in particular basically expands that Objective-C frameworks to provide mobile-specific functionality. Touch and mobile devices are very specific, multi-touch events, multi-touch controls, accelerometer. All this stuff is not things that you need on a desktop laptop. So it's important to understand that this Cocoa Touch library really is kind of at the fundamental base of a lot of things you work with for the iPhone. There's also this mention of Swift, and a lot of people say, what is this Swift thing? Objective-C is hard enough. What is Swift about? And just a phrase right from Apple, Swift is a general purpose multi-paradigm compiled language. It's developed by Apple for iOS. You can use it for macOS for the watch. And it is designed to work with Cocoa and Cocoa Touch, which is Objective-C. So the interesting thing about Swift is that it is more JavaScript kind of based. It looks a little more like JavaScript. So it is definitely friendlier than Objective-C. So if we have Cocoa Touch that's at the base, and we have Swift that is now involved, we have this rich set of Objective-C libraries, and then we have Swift, which is really almost like a friendly face to Objective-C, right? So we understand this Cocoa thing's involved. We understand that it encompasses these bodies of languages, whether it be Objective-C or Swift. And this is kind of an example of a small difference between Objective-C and Swift. On the left, you can see it looks a little more like JavaScript. Objective-C is a little more terse. It's certainly approachable for some, but it's not as friendly. So Swift, to expand on that a bit more, the really neat thing that Apple did is they said, we don't want to offer yet another programming language unless it all interoperates together. And so one of the nice things about Swift, it lets you interface between Swift and Objective-C code. You can use Swift classes in Objective-C and vice versa. There's a particular magic they use to do that, which I want to get into. But the mix and matching of these two languages is really important to know when you start wanting to develop more and more for iOS. So, obviously, as web developers have this really rich set of open source libraries on NPM. NPM registry has a ton of libraries, and so Apple developers are also it's just as thriving of a community. It's probably slightly smaller just because the web community has become so large, but there is also a rich set of open source libraries from Apple developers.
And where's that at?
Where is it at?
Yeah.
So CocoaPods, actually it's not this. This is CocoaPods, and CocoaPods is actually really this entire open source sharing. They definitely encourage sharing of open source libraries. They could be Objective-C based, they could be Swift based. Sometimes you'll have even watchOS specific libraries. It's a wonderful place, just like NPM.
So this is like NPM for iOS.
It's very much like NPM for iOS, and in fact, the way you interact with it is very similar. It's definitely not identical because you're installing NPM packages with the NPM tool. CocoaPod has their own tool, and it ties everything together. So this is kind of just straight from CocoaPod's site here. On the right, there is some really cool stuff about it in similar way that NPM makes things very convenient. The CocoaPod allows you to define the specs where they are, where the repo is, and then also dependencies. So just like in a package.json file in NPM could actually define dependencies and dev dependencies, you can also have the same type of dependency set in a CocoaPod. So a CocoaPod may depend on some other framework altogether. This pod file could actually define that dependency. When you install this, pull everything down. The neat thing about the way that they design CocoaPods is that they're split up. So it actually installs two different projects and one that manages the CocoaPods independently of your actual Xcode project. This is important to understand because when you start integrating with CocoaPods, there's actually two Xcode files that are generated. Generally, when you create an iOS project, there's one single Xcode project file, but the second you start integrating with CocoaPods, you'll have two. One is a workspace file, and the workspace file actually brings the two worlds together. It basically brings CocoaPods in with your project. And so often you always want to work with the workspace file when you're dealing with CocoaPods being integrated.
How important is that?
It's very, very important. If you actually had tried to run your project from the wrong Xcode file, it will crash and burn. And actually it won't be able to find anything. It wouldn't even be able to compile. So it is very important.
Okay.
So if just in numbers, just to kind of give you an idea, you know, we got a couple thousand libraries there on CocoaPods, 37,000 to be exact on recent numbers, you know, over 500,000 about on NPM. So obviously the NPM community is quite large. The interesting thing is that some of those NPM numbers are actually from NativeScript itself, which pull in CocoaPods. So some of the numbers on NPM are actually CocoaPods, which is interesting. So how could we use these CocoaPods with NativeScript? There definitely is a very, very simple way to do this. You
need a new TV.
You know, you thought the connection would be better in New York. All right, so there is a very simple project structure to these pods, and very similar to how you were shown on Android, where the source would be at the root. We're actually looking here at the source of a plugin as well. NativeScript prefers this very specific structure where you got a platforms folder inside the plugin folder, and then an iOS folder to designate these are very iOS specific files. The pod file is nothing to do with NativeScript. That is all Apple development. And to look at what the pod file includes, it's simply just a pod declaration. So this pod declaration is all you need. It's actually surprisingly simple, and you feel like you might be missing something, but that pod declaration right there would pull down the SwifttyCam CocoaPod. It would actually integrate the whole CocoaPod into your iOS project. When you run your app, you would have all that code now available to you.
And you say run your app, you mean the NativeScript app?
The NativeScript app. So as far as including all these rich set of Objective-C and Swift libraries in your NativeScript project, this is how simple it is. Including the pod declaration. You can go find any CocoaPod out there you want, add this CocoaPod inside of this proper structure, which is just the platform's iOS. It's not complicated. And you put this pod file in there, declare it, and NativeScript will pull that in. Supposedly. Doesn't get it actually does not get added automatically.
So there's another step?
There is another step.
Okay.
So generally what you'd want to do when you do this, and there's a number of ways you could really integrate CocoaPods in, but the ideal way is to really set up an internal plugin folder. And this internal plugin folder would be inside the root of your own NativeScript app. This is one of the ways that I personally prefer to integrate with native APIs. It's the quickest way because you're working within your app and you can right away start actually developing with that code and develop it out, which you may later want to open source and publish as a plugin. That is is something I do sometimes, and I think you guys do as well. So
Occasionally.
sometimes it's nice to share it out and let everyone kind of improve upon it. So this is a very basic structure, but because NativeScript works within this web scope of development, I think someone mentioned earlier today that one of the goals of NativeScript was try to bring kind of this web development frontier, you know, kind of in the native space. And so we have this ability to integrate with these native APIs through NPM. So this NPM package.json, all we're saying here is that we got the name of our plugin here. We're going to version it just because version is required by NPM to have in your package, and it's definitely a good thing. You're going to want to version your plugin. And then inside you have a NativeScript P. All this is saying is what platforms in NativeScript are supported by this plugin. So right now, if I was just integrating with a CocoaPod, I'm just going to support iOS. So I'm just going to indicate the minimal version of NativeScript.
Do you know if that works the same way for Android?
This is the same way you would do it for Android, actually. You might have the same package file, but you might add an Android key under platforms with the same minimal target.
Okay.
So the minimal target is just saying that this plugin specifically is going to work from 3.0 and beyond. There's obviously NativeScript 2.5, which a lot of apps still use, and you could target 2.5, that's fine. They change a little bit of their lifecycle hooks with NativeScript 3.0, so it's usually a breaking change between NativeScript 2.5 and 3.0, especially when we're talking about Vue plugins.
Okay.
Okay. So we've got this package file here. It's sitting within the structure of our internal plugin here. We're doing this mainly so we can add this plugin into our NativeScript project. So what we can do at this point is we can say TNS plugin add NativeScript my plugin. What TNS is going to do is it's going to default to look locally first. So it's going to find NativeScript my plugin is a folder right inside the root, and it's going to see that, and it's also going to pick up the package.json because TNS works with NPM. And so it's going to say, I see a package here, and it's going to add that plugin into the NativeScript app's dependencies. What that's going to allow us to do at this point is it's going to automatically pick up the pod file, and when we build iOS in NativeScript here, it's actually going to build that CocoaPod into our iOS app. So this is kind of a view of what happens after doing TNS plugin add. We've got a local file include for this local plugin. That is just going to reference it locally. You could reference any other local plugins, of course, in the same way.
Excellent!
And that's it. We actually are ready to code against this Objective-C in Swift code right now. That's all it took.
So
that's pretty simple. I mean, there's a little bit of a learning curve for sure if you don't know the pod file and how to specify the dependency, but that looked fairly simple to add that to the NativeScript app.
It is pretty simple. It's really surprisingly simple. Now the thing is you got Objective-C and you got Swift code, which we were talking about. Kind of introduces this very interesting situation you can run into. What's very important to understand is that NativeScript works with Objective-C directly. It does not work with Swift directly. It actually works through Objective-C only by the Swift bridging header, which makes the Swift code available to Objective-C. And since NativeScript can work with Objective-C, that's how we as NativeScript developers can actually work with Swift. There's been some talks to actually create a runtime that's specific to Swift. And I'll talk about a couple of those things and a couple of the challenges. So one thing I want to mention is that when you start integrating with a CocoaPod, one thing that's really nice to do is create and isolate that plugin integration. This is really important because there's a lot of native code you could start typing in here. You could start typing all sorts of stuff against CocoaTouch, against this CocoaPod you included, and you want to be careful about how you intermix that into your app code, because who knows, down the line you may want to pull that pod out. Maybe it's terrible. Maybe you've gotten 2 months down the line and this pod doesn't actually do what you want, or worse, has a crasher and actually ends up crashing your app, and you gotta find something else that's going to work better. For this reason, it's a really good practice to isolate all the plugin code inside. I'm going to use TypeScript as an example here, but inside this plugin folder here, I've got a my plugin iOS TS. This is a TypeScript file. I'm just exporting a class. It's got the suffix on there. NativeScript is going to pick up that suffix and actually exclude the suffix, build it into just myplugin.js when it runs a NativeScript app. So it's just included like a standard JavaScript file. But let's say we got this class sitting here. And what we really want to do is in the package, we got to make sure that NativeScript knows now that we want to isolate this native API code into this very specific file. And the only way to do that is to tell the package.json that the name of this JavaScript file specifically is going to be called myplugin. MyPlugin, notice we don't use the suffix there.
Why?
The suffix is excluded automatically by NativeScript. When we build TNS run iOS or TNS build iOS or TNS run Android, that is what's going to tell NativeScript to say, oh, I'm building for iOS, I'm going to take all the suffixes out, and the JavaScript it ends up with for the Android build or the iOS build don't have any of those suffixes there.
Ah.
That's important to know as a plugin developer because you want to develop platform-specific plugin code. So this very specifically is for iOS. I'm telling the main that it's just my plugin, and very curiously, I'm leaving the .js off.
Why is that?
You want to leave the .js off to allow other developers and people who might use this plugin to webpack it. If you have the JS on there, you're going to cause all sorts of problems for Webpack. You want to leave the .js off in the main key in your package.json. It's very important.
Who thought of that? Was that Sean? Sean Larkin?
I wish I knew who thought of that. I don't know if there would be workarounds to that, but it's not a workaround you want to toy with.
Fair enough.
So we're going to leave the .js off, and we're also going to specify a typings file. So we have a couple options as a TypeScript developer. We might want to allow someone to actually integrate with this plugin and get rich, strong typing on our plugin. We could create a rich service library with very specific methods, signatures. We want all of that stuff to be strong typed, so when the developer uses it, they actually get errors at compile time. It's very nice. So one really nice practice to do is to add a typings key in the package, specify the name of this typings file. I'm just going to use index.d.ts, and I'm going to update that manually. This is an example of what the index.d.ts for this class would look like. And this is just declaring that there is a class named myPlugin. In doing so, basically will allow me to import that symbol. If I do import myPlugin from this library, this plugin, I would actually get strong type checking against everything that's defined in there. Now, of course, you can also have TSC actually generate the typings for you so you don't have to manage them manually. But it is nice to have an index file that you can condense Android-specific and iOS-specific typings down to one file. Because when you TSC compile .iOS, or .android, it's obviously going to generate typings for .d.iOS and .d.android. So you'd have two different typings filed there. And you really want to bring a common denominator down to a single typings file because as a plugin developer, you really want to make sure your API is the same across both. That's the beauty of NativeScript is you can provide the exact same API on two totally different platforms running two totally different languages.
That makes sense.
So there is a thing that this CocoaPod in particular, it would be amazing, right, if we could generate TypeScript definitions for this native code.
Yeah.
I mean, it'd be pretty mind-blowing.
It would be very cool.
There actually is a pretty amazing ability of NativeScript to do this. I'll talk a little bit about the development workflow for this plugin code before I show you the TypeScript declarations and how we could actually do that. So one development workflow, if we were going to go with this internal plugin structure inside of our project, like one way would be to make changes to the plugin code. Then we could compile that plugin using TSC. We could pass the -d flag. That's going to give us our TypeScript definitions off that iOS file. And we're just specifying to compile that one file. We're doing this is very manual. This is one way you could do it, and it works just fine. This is going to generate the TypeScript definition. I would usually take those definitions and then copy and paste them down into the index file, because I like to manage this index file. It's just it's a nice way to do it. Then to have NativeScript pick that up now, because we've made changes to the plugin, you can do a remove, which is going to remove it from the native Xcode project, and then we're going to add it back. This is one safeguard you can do, because sometimes in native development, when you make changes to the CocoaPod or you make changes to native files, the Xcode can be funny sometimes. So it's a good practice sometimes to remove the plugin, add it back. It takes 2 seconds. You're safe. When you run it, you know for sure that's going to have your changes. Lastly, we run iOS. That's going to pick up any plugin changes we made and actually include the native plugin. So if we look at the steps to these CocoaPod TypeScript definitions, because we don't want to work willy-nilly and just think that we're typing against the right thing or right method call, not to mention that methods have an interesting way of compounding each other when you look at Objective-C method and how it translates to NativeScript. So first off, we want to install the TNS platform declarations. These are awesome. This is going to give you rich IntelliSense off iOS and Android, all the native APIs. And then in addition, what we want to do is add this references d.ts file in the root. So out of the box, when you create a NativeScript project, you don't have this references d file. This could change in the future, but right now there's no references file to start. So you want to add this after you add these platform declarations. And then you want to include these 2 references. They're basically going to reference all the definitions for all the APIs on iOS and all the definitions from Android if you're doing Android development. And then we can run this command. This is a global. You could set this in your bash profile if you want, if it was going to be the same folder you always want to generate these typings in. But this is going to actually build the app, but this time it's going to queue the NativeScript CLI to generate metadata for all of the Objective-C third-party code that you have in addition to all the native code in your app. So this is an example output after building the app. We can actually see that the CocoaPod SwiftyCam that we'd included is installing. This is a really, really good sign. This will let you know for sure, okay, I've got the CocoaPod included right. Looks like the version number's right. You might even see version number differences there depending. That's a good thing to kind of keep a note of, because sometimes the versions can be vastly different, of course, between one CocoaPod and the other. So what that's going to do is it's going to generate this typings folder. This typings folder is going to have 2 folders in it, one for the simulator, which is i386, and then you've got ARM architecture, that's 8664. That's generally for a device. The difference between them does not matter. I would pay no attention to it, because generally all you need is everything that's inside of one or the other. We're just going to look inside i386. We can see all these Objective-C bang, and then it has the name of the class. These classes are all straight from CocoaTouch, which we were just talking about. Again, CocoaTouch to CocoaPod to this, what we see here. It's important to know that's what we're looking at. Furthermore, what's really cool when you do this is that it actually generates the TypeScript definition file for the third-party pod that you included. So this is actually the TypeScript definition for SwiftyCam. And NativeScript created this for us. This is actually a full, completely valid TypeScript definition for this native class that we just included. This is a Swift library, for instance. And this has all the invocations that we need to know about.
So as a developer, if I add these definitions for that pod, it's going to provide me with some good IntelliSense as I'm developing, correct?
That is correct. It's going to give you, not only that, but it's going to let you know what's even available, because some things might not be available.
You mean you don't have to guess what the name is?
You don't even have to guess what the name is.
Wow.
It actually is kind of mind-blowing. So, Objective-C has very interesting method signatures, and they can be very unwieldy sometimes, and even difficult to understand how to translate that. So doing this TypeScript definition actually alleviates all of that, because you don't need to know how to translate it. It actually is completely type checked for you. So the workflow I was just showing with the internal plugin and actually compiling that is quite a burdensome workflow. We're talking about compiling with TSC manually a plugin that's inside your project just to get a JavaScript file out of it, then removing the plugin and adding it back to actually get that plugin in your project. That's
It seems like a lot of work.
it's a lot of work. So if we're looking for a faster workflow, one I really like to use is actually take the plugin code, put the file right inside your project. Keep it inside a folder because, again, it's still important to scope your plugin integration in its own JavaScript file. This is just going to help you in management in the future. It's also going to help you stay focused when you're dealing with this native code. So we're going to take that iOS file that we had inside of that My Plugin folder. We're just going to drop it right inside of our app folder. This is going to give us the ability to work with it directly inside of our project, alleviating the entire workflow that I just mentioned.
Wow, that's pretty cool.
It's a nice way to do it. And this is the definition file. So again, when we were looking at the plugin, we had an index.d.ts, but that's kind of irrelevant because the index.d.ts was purely for the folder in the package.json, which is meant to publish. So if we're going to have a package.json and we're going to have typings, those typings only need to specify index.d because number one, it's a good practice, but also number two, it's going to include those typings for that plugin when someone installs it. So if you're going to share your plugin, the typings is important. But here, we just want to develop fast. We want to be able to work with this plugin right away. We don't want this burdensome workflow. We're not going to publish it to the world just yet. We need a couple months working with this thing and really get it figured out.
So by moving it into the app folder, what does that do in regards to the path?
So what we can do, the thing is that you got to keep in mind here is because iOS is on the end of it, you can't import from .ios. You wouldn't want to do that because NativeScript is going to remove the iOS extension. So by the time it builds down to JavaScript, your import path is going to be wrong. So you need a definition file internally that just declares the name of the class. Now you don't even need methods or properties inside of this definition. That's kind of irrelevant here unless you want type checking for yourself, then it's totally fine. You can put those here. But mainly what we want to do here is just allow us to interoperate with this plugin inside of our app and get around the TypeScript hurdle that we deal with this iOS extension on the end. So this declaration file is saying that we got this My Plugin class. That allows us to now import it inside of our project as we would any other class. So we can see we're importing from the My Plugin folder and specifically the My Plugin file. This is a TypeScript file I'm importing that from, and we can see it's coming from just My Plugin. Why? Because that's the definition file that's actually getting picked up by TypeScript. When NativeScript runs that though, and it actually enters the runtime, that is going to load the actual JavaScript compiled file. And the TypeScript definition is meaningless in the runtime environment. So if we go back, we're going to take a look back at this package.json here. Okay. We want to talk about these CocoaPod definitions, but specifically we want to talk about how we can get the strong type checking against that CocoaPod. So if we take a look here, this is that Objective-C class that we had generated for us by NativeScript, and we want to get the strong type checking right within our project. We want to be able to construct the SwifttyCam button. We want to see all the methods available to us. What we're going to do is we're going to remove all of the other folders that NativeScript generated for us in the typings file. So if you remember, there was an i386 and there was the x86-64 folder. Those are meaningless. We don't need them anymore. The only reason we generated this was to get a TypeScript definition just for this CocoaPod. And it's worth noting that when you start integrating that back and you bring that plugin directly into your project, you do want to fix your package.json back to normal because you no longer are using that workflow anymore. You instead are including the plugin directly in your project. You don't need a main here because the JavaScript file doesn't exist inside this folder anymore. We're just keeping the bare bones package setup just so we can include this by name into our NativeScript project. Just to bring the CocoaPod in, that's it. We're not going to use any JavaScript inside of this plugin. This is what you'd call a CocoaPod only plugin with literally no implementation. So back to this declaration file. We've got it included. We've got the references file here. We've got iOS and Android. We're going to include one more declaration at the bottom there, and that's to this Objective-C SwiftyCam declaration file. I've got it sitting right there inside of the typings folder, and that alone is actually going to allow rich IntelliSense when working with that native library right inside of our project. So here I am right inside the Hello World demo. This is right from a bare bones setup for NativeScript, and I'm already getting IntelliSense on Objective-C code right here inside of this demo code.
Sweet.
It is pretty amazing. So there might be a couple problems with this though, because as I mentioned, it was built with Swift. So,
oh my God, look at that face. You look like my next mistake.
Well, yeah, I mean, it is a mistake because when you start working with Swift, there's a lot of problems that can happen, and you are going to run into some stumbles. And the main problem is that Swift is an advanced programming language. Objective-C is kind of basic in terms of modern-day programming languages. Swift introduces these advanced enum structures. And this is probably the most critical component that you run into in NativeScript development, because any Swift library that uses an advanced enum structure is going to be completely ignored by NativeScript.
By advanced, you mean just a typical enums?
So that's a good question. So this enum we're looking at right here, if you know, an enum is just, it's basically enumerated from 0, 1 for every single case that you have inside the enum structure. But what Swift allows you to do is not only have from 0 to whatever enumerated options, you can also have properties and even methods inside the enum, as if you really needed that.
Wow, I can't think of a good use for that.
It's definitely advanced usage, and a lot of Swift developers today are doing it because it's cool. There are a lot of these advanced enum structures. This library in particular is an example of that. So in order to work with them, we do need to do a couple things. So we've entered the territory of, we do need to make a couple modifications to the native code. And we need to do this because we want to interact with this library with NativeScript, but we want to open up this Swift library entirely to Objective-C.
If this had been written with Objective-C, you wouldn't have to do this.
That's correct.
Okay.
This is just a Swift issue.
Okay.
So we're going to look at this TypeScript definition file, and what you'll notice in particular is that with everything collapsed, we only have 4 declarations here. And if you notice, so if you'll notice here, these enums are not mentioned in that definition file. We've got a camera selection enum and we've got video quality, but if we look at the definition, those aren't there.
So in basic terms, NativeScript doesn't know they exist?
NativeScript doesn't know they exist.
Oh.
So this is a problem that we have to deal with. And you can see if I search camera selection, that enum is definitely not there. And what is also important to note is that for any enum that is omitted when compile time happens and NativeScript doesn't know about it, it also will not know about any other method that uses that enum, whether that enum be in the method signature or used within the implementation of the code.
So you mean you could be missing properties and functions?
All sorts of stuff. So there is a nifty thing that they introduced actually back in Xcode 6.3. So this was actually a couple of years ago. This has been available. What you can do is you can use this @Objective-C attribute. This is kind of like the decorator in Java, where we had @override. It's somewhat similar. What it's doing is it's flagging the compiler to actually say, you know what, we want to expose these properties to Objective-C. And so this @Objective-C declarator is going to allow us to do that. Also in bold, you can see 23 upvoted. There definitely should be more upvotes. This is how stingy iOS developers are. This is definitely one of the most important answers you could get on this topic. There should be over 100 upvotes on this one. But you can see in bold, you must declare an integer raw type. This is critical, especially with these enums. You can see @Objective-C enums must declare an integer raw type. It could not be more clear. So in order to do that, what we'd have to do, we want to work with these enums. We want to interact with this code. We want to convert this to look something like this. And the difference is just that Objective-C modifier that we add in front of the property, and we can see we add a :int. Just as that Stack Overflow answer mentions, it must extend the int raw type. Those two things right there is what's going to open up this entire Swift library to NativeScript. It is one of the most important things to know when interacting with Swift, and it might be the only strange thing that you encounter with Swift in integrating with NativeScript. In fact, to date, for myself, it is the only thing that I've encountered where I need to modify Swift code.
So other than this, you've never had to really touch the Swift for a CocoaPod?
That's correct. Okay. So as we can see, add Objective-C modifier there. We've got :int that's extending that. Let's look a little bit behind the scenes of why this is important. And you can kind of understand what's going on. If we look inside of the project, in Platforms iOS, in the build for the emulator, we're going to follow this path down to what it built for our iOS simulator. We're going to see inside we have this SwiftyCam framework that NativeScript didn't do it. This actually is built by Xcode, because NativeScript, when it builds iOS, it actually uses Xcode build, which is a command line tool installed by Xcode, and it runs Xcode by the command line to build our project. NativeScript is not doing any magic here. This is just iOS development. The SwiftyCam framework is created by Xcode build. That is our CocoaPod, and you can see it generates these header files. These header files tell the runtime what is available to call, what the signatures are, and what exactly we have access to. In particular, you will find on any Swift library you integrate a -swift.h file inside of this folder on the framework. This is what's called the Swift bridging header. It is very important. It can also be used to determine what is available. Whatever is not in this file, NativeScript does not know about when you're integrating with a Swift library. This is a critical thing to know and understand. This right here is a look at what one of these header files looks like. It is not something you want to read casually. It is very terse, but it basically defines every single property that might have been coded inside of the Swift library and tells Objective-C, hey, you can work with me through this. I'm giving you the map to my code. This is the map to the Swift code. So what we want to do is we modified those ints, and now what we want to do is we fork that library. That's an open source CocoaPod. We may want to contribute this back to the author. We may say, hey, you know what? Actually, it might be awesome if your code actually worked with Objective-C, because who knows? Maybe somebody else is using Objective-C with your library, and they'd like to work with it too. So you might fork this and actually submit a PR back to the author of that CocoaPod to help improve their pod on this basis. Some Objective-C developers do not care, or Swift developers do not care, so don't expect it to be merged. But at any rate, you could do that. Now, we've taken the fork, and what we want to do is we want to change our pod file to designate this custom fork. This custom fork now is going to actually be the version of the pod with our add Objective-C modifiers and the int raw type extension on these enums. This is how we can get past this Swift barrier with Objective-C.
When you do that, you're actually bypassing the CocoaPods repository that houses that pod itself.
That's correct. We are going to actually pull directly from our repo on GitHub now. With those changes that we made, we push those up. And what we want to do when we make a change to the pod file, it is important, like I mentioned earlier, you've got to remove the plugin and add it back. You're making changes to the CocoaPod. Those things are deep down in the build project that NativeScript already made for the Xcode project for iOS. You got to remove that and add it back to make sure that that CocoaPod change that we just made to use our repo is actually included. And now what we can do at this point is we can regenerate our TypeScript definitions. So we can say now, okay, well, I've made those changes. I want all the typings now. And I mean all the typings this time, not just a few of them. So this time when we run our project, we'll see, and again, this is another good sign. You want to make sure we've made changes to the pod. It's going to pre-download SwiftyCam from this custom repo that we forked and made the changes to. We can see that right here in our runtime.
If you don't see that, what do you do?
You definitely did it wrong. You want to check your syntax inside the pod file, and that's one thing to double check. The syntax for the get is very Ruby-esque for those who are familiar with Ruby, but we're designating that this get is actually our repo. So sometimes you might have that declaration wrong, maybe you accidentally put a space between the colon on the get, maybe there's not a comma after the pod declaration. Those things are important here.
And if that's correct, have you seen that ever before?
I have not seen an error because I never make a mistake.
Oh, awesome.
I actually have never seen a mistake in a pod file specifically, but I know it happens.
No, I just, what I was wondering about is if you've ever not made a mistake there, but then it didn't pick it up.
I have not seen that happen unless you're dealing with an updated version that is published on CocoaPods. So sometimes an author may publish something that is like today. Let's say someone publishes a CocoaPod today. CocoaPods use this spec that's installed in your home folder, and it's kind of like a master lookup table of all the current specs on CocoaPods. They use this for cache reasons. It's also just helpful to the whole CocoaPod install system. So when you go and install a CocoaPod, if there was an update to it, and you were using like a caret or a tilde and it pulled the latest version, it's possible you might get an error and it might say that spec doesn't exist. And you may say, yes, it does. I'm looking right here at CocoaPod publish directory, says version 235. It definitely exists. The problem in this case is that your local specs are out of date. Usually CocoaPods, which again is a command line utility that you get along with Xcode, it's just part of the OS 10 development tools. It will tell you that you need to update the pod repo. And this is usually something as simple as pod repo update. And that will update all the specs locally. Then you can run it again and it will see the CocoaPod that time. So we've got these changes done. We're going to regenerate these typings. We've got our declarations path. This is just a global variable that we're setting in the shell that NativeScript is going to pick up when it builds our project. But it's going to queue up the metadata generator when it makes the build, and it's actually going to generate all these TypeScript definitions for this pod. We can see it's got our repo right there. This is definitely should be the right one with the changes. And sure enough, when we look at that definition file, we now have a lot more properties. Actually, there's a ton more stuff that opened up. We just opened up that camera selection enum that I was just talking about. Curiously, you might note that by default, when these are created, it actually uppercases the enums. That's a critical thing, but again, you've got the definition file there, so you're going to get strong type checking against this. So you wouldn't accidentally do a lowercase r because your TypeScript compiler would actually stop you. But that's an important thing to note. This is the look at now the Swift header again. So this is after we have made our changes. We've rebuilt the project in the compile time, not NativeScript. This is just iOS and Mac development. Regenerates the Swift header file, and now we have these Swift enums opened up. You can see the type def. This is what is saying, hey, Objective-C, I am now defined, and you can work with me.
First, the bad news. 3 out of 4 unsuspecting people will get gingivitis, an early form of gum disease. Now, the good news. Listerine Antiseptic is the only non-prescription mouthwash accepted by the American Dental Association for its significant help in preventing and reducing plaque and gingivitis. And Listerine still kills bad breath germs.
Plugin layout. Why does it matter?
Does it really matter?
I think it does. Since we've been doing plugins for a really long time, at least I believe you have, Nathan, one of the original ways that we did plugin layouts was to create a master folder, like in this one, the XO player, and inside of it there was a demo, and then in there is the platforms file that we've been talking about here, and then there could be other screens and other folders in there, like in this case there's the screens that has like screen pictures, and then there's a couple of subfolders that have different source code in there. And then there's the npm ignore, the get ignore, and then the rest of the source code, and you can see all that stuff there. This used to be the way we used to generate plugin folders. It's very simple layout, very good for demos because you have your demo folder right there. Everything is all just self-contained. Why do we use it? Because it's very simple to link to. Like Nathan was saying, we could easily just do npm or TNS space plugin space add dot whatever the name of the plugin was, and it would just pull right in without a problem. From the demo, you could do TNS plugin dot dot add dot dot, and the demo folder would add the root folder. And so it was very simple for your plugin layout, the plugin layout for GitHub. Why are we abandoning it? Because you will notice that Nathan had a slightly different structure earlier. It is because of changes in the NPM tool.
Do we have to abandon NPM?
No, we're not abandoning NPM. We're abandoning that structure of the layout. You'll notice if you start looking at the plugins, if you do searches, and you'll even find several of my plugins still have the old structure. And if you try to run the demo, you might run into issues.
So we're changing a plugin layout just to suit NPM?
That is correct.
Go on.
The reason we are abandoning it, and so this is why you will see differences in the two different plugin designs, the way Nathan Walker described it earlier, and the way you will see a lot of plugins still existing, is because when you do a TNS plugin add or an npm i.save, which are basically the same thing in this case, both do this to your node modules folder inside the demos folder. And if you guys look really close to the highlighted line, you'll see a little tiny thing like that. That little symbol is a symlink, and a symlink is basically a pointer back to the folder. It's not a copy of the folder, it's just actually links you back to the original folder.
This sounds pretty gross.
It is, but it has some benefits too. The symlink points you back to dot dot, and so why is it so bad? Because this is what your dot dot folder looks like. What is that top folder there? The demo. So your demo folder now inside its node modules is pointing back to itself because NPM linked you to the root folder.
That sounds really bad.
That is very bad. Yeah, it's your demo folder. And because you're linked to your demo folder, it's not only bad because you have 2 copies of your TNS runtimes in there or your core modules, but it's recursive because now you're linked to the demo. The demo is back into here. Your node modules is linked to your demo. It's back to, and so you're basically, when TNS tries to install, when TNS tries to compile, it goes down this path, goes down the path, goes down the path, goes down the path, and it basically gets lost.
This sounds real scary. It actually makes me need to pee. I got to use the bathroom. I'll be right back.
So the better way, which Nathan was showing you earlier, is you create your demo folder and then you have a source folder under that. That way you can link to the source folder, and when npm does a link, it will link to that folder, and so all your stuff is inside there. So you have your platforms in there, npm ignore, your TypeScript files, your licensing. Actually, licensing can be in the main one. I like to put it in that one too because when you're creating the plugin to put on npm, that's the one that's going to pull is that license. Your package.json, your readme, and then your source code files.
And this looks very similar to the official seed.
That is correct. The official seed structure changed in some regards because of NPM and because of the issues that they ran into and I've run into. So now when you do from your demo folder, your demo Angular folder, the .source, the link still exists, but the link is linked to your source folder, so there's no longer this recursion. It no longer happens. In addition, this offers a brand new method to do plugins. Nathan was showing one of the older ways that we devised a long time ago to help speed up plugin development. With the new version of NPM, because it links back to your source folder, and that gets linked into your node modules, you can leave your source inside that source folder. You don't have to now put it into your application like Nathan was doing, although sometimes some people like to do it that way. But you can just have one copied source and leave that source always in that source folder, no longer having to move it around when you're going to release and whatever else. Because there is a new command line on TNS. There's this TNS run iOS -- sync all files, or TNS run Android -- sync all files. And what that does is that creates, when it's doing its normal watching of the normal directory, it actually watches your node modules directory. And because your node modules is linked back to your source folder, it's now watching your source folder. So when you make changes in your source folder, TNS picks it up and automatically pushes it to your app, just like if it was just inside your normal thing. So the NPM side effect that was bad for our old structure actually gives us a good side effect in the new one, because with the prior way that we were doing it, I always ran into problems where, which one of the copies was I working on last? You know, was I working on this one or was I working on this one? Oh, I need to just do a diff real quick. Okay, so this is the one. Now you can just leave it right there and you don't have to worry about it ever again. So, plugin listings. So after you've got this plugin all done and you're all ready and it's cool and you want to let other people use it, and how to get it, how do you get people to use this plugin? How do people know it exists? Well, the important thing is in your package.json file, which we worked through earlier, you add NativeScript somewhere in there. You either add it in the name of it, it's like nativescript.wikitude in this case, or whatever the name of the plugin is. If you prefix it with NativeScript, it'll be picked up by all the plugin sites. Or if you're trying to not put the NativeScript branding in it for a particular reason for your own company, you can put it inside the keywords. The keywords, if you have the keywords with NativeScript, the plugins will be picked up also.
And what is this plugin site you're talking about?
There's a couple of them. They introduced the new marketplace earlier today. And then there's also this plugins.nativescript.rocks, which has been around for a while. Those are the two big ones. There's a third smaller one.
So you're kind of like the rock and roll guy behind NativeScript.
I wouldn't say I'm the rock and roll guy. I am behind the NativeScript rock sites, but yes.
How many of these rock sites are there?
There is about 5 now.
And what are those 5?
The first one is this plugins. Then there's just the basic NativeScript rock site, which basically links to different resources. There's images.nativescript.rocks, which deals with creating your assets for your thing. You can upload one picture and it'll create your screens or your thumbnails or whatever else in all the right sizes. And then there is a new site that is to be released today, actually, called searchcode, which I was going to go into in the demo, but I don't think I have the slides for it now, which allows you to, I'll actually get into it a little bit later on the search code. And then there's a 5th site that is unreleased that will be released shortly.
So there's a couple different sites to look for plugins. This plugin.nativescript.rocks. There's plugins.nativescript.org.
Plugins.nativescript.org is probably going to forward to market.nativescript.org. If they do it right, that's what they're going to do, because the marketplace was just released today.
So there's a lot of ways to find plugins.
Correct.
Okay.
And so when you do put this NativeScript in your package like that, then by default, both sites will pick it up. How quickly does it show up? I know on my site, it's instant. I mean, literally the minute you make the change, NPM notifies the site and I've got the new data. So if you release a new plugin, you should see it almost immediately. If it doesn't, you know something's wrong. I'm not sure about Market. I don't have anything to do with them. They may be using the similar code base where it picks it up immediately. If not, the old plugins.
That's the verified plugin. That
the verified plugin.
On today's show.
Yeah, the marketplace. Right. That could be within 24 hours, but it should show up. How important is this platform's key insight? This is the package file, by the way, and Nathan went into a little bit about the iOS. and there's Android. These are putting those platform keys are critical because this really tells the sites, does this plugin work for iOS or does this plugin work for Android? If you don't put it in there, it really is up to the plugin site to decide what they do with it. Some of them will exclude it, some of them will assume you support both. But it's pretty critical if you do it to please put in whether you actually support it. Some sites add additional data, like this whole plugin key you see where it has nan, pan, core3, view, webpack, category, and wrapper. Those are all things that actually Nativescript.rocks does. It's not something that the marketplace does to my knowledge. It adds a little bit more data. So like nan stands for Nativescript Angular. So if your plugin supports Nativescript Angular, the way you can mark it so that it shows up on the site is put nan true. Pan is plain, which is defaulted to true, so you don't normally have to do that. Normally you put a false there if you know for sure only works with Angular and doesn't work with whatever else. And so
that plugin key is only for Nativescript.rocks.
At this moment, to my knowledge, it is. I'm the only one who uses it, and it's documented on the Nativescript.rocks site for all the details of it.
Okay.
And then down below is the demo keys are also Nativescript.rocks unique. I do attempt to find them inside the thing, but that doesn't mean if you didn't name them something standard like demo or demo ng or demo-angular, if you named it like my demo, my site nor marketplace is going to find it. We're not going to know there is a demo for this, and it's nice to know if there's a demo for the plugin. And you can read more about it on the plugin site. Anything more basic that you should know about? The npm ignore file is, in my opinion, very critical. When you create your plugin with TypeScript, you do not want your TypeScript code in your plugin that you're distributing on npm. The TypeScript's useless to the end user. You want your definitions, the user needs definitions, but you're just increasing the size of your plugin and increasing the size of the application for no reason.
So the npm ignore is just for when you publish your plugin? That
is correct.
Is it used for anything else?
Not in NativesCrypt terms. I mean, npm uses it for other things, but if for our purposes, what we're doing with npm ignore is to make your plugin size as small as possible so that the user, when they're putting in your app and putting in their app, their size is not bloated. Because I mean, if you have screenshots in your folder for showing up on npm and showing up on the plugin sites, their documentation, you don't need those distributed with your plugin. So
I would imagine TypeScript files too could cause a problem if you published a plugin with TypeScript files, because sometimes depending on your TS config, it may pick up TypeScript from your node modules. So it could wreak all sorts of havoc if you have TypeScript files in your plugin.
It could throw errors, yes. If you told your TypeScript to ignore errors or emit with on errors, your app would still compile properly. But if you're one of those people who like strict, doesn't want to see any errors, and so you don't let the code be generated, it will stop you because those will be trying to link your TypeScript files. They will be trying to link to directories that probably don't exist. So yeah, removing TypeScript is normally one of the things you want to remove from your npm ignore. And then your GitHub layout is still recommended. I know the marketplace uses demo and demo angular. Demo view is something brand new because the new view integration. I don't know if marketplace picks that up. The plugin site does pick it up. And then the source code, actually the source is really what you want to name it. I just named mine source because it makes sense. And then the git ignore goes in the root folder, because Git, you're typically you're writing everything from the root folder into your GitHub account or your GitLabs or whichever one you're using. Where the npm ignore goes into the source folder, because only the stuff inside the source file folder is what you want put into your npm package that gets put up on npm.
It's kind of confusing because like you're used to working in source, and then on the web you might have a build directory called dist. Mm-hmm. It's the build directory that you want to publish. But you're
Correct.
saying here it's literally the source folder.
That's the way I do it. There is, I mean, you could, if you're using TypeScript, you can have TypeScript output to another folder, and you could do the same thing where you created a dist folder and then you would put the npm ignore in there. The npm ignore really is for when npm is set to go pack or publish your plugin up to the site. Third-party integration. We covered that a bit earlier with both Brad and Nathan on Angular and, I'm sorry, not Angular, on Apple and Android. This is a little bit more in depth here. They covered some of this. The platform iOS folder, where you put your pod file, that's very important. The pod name, you can actually specify a pod version. That is also can be very critical. Sometimes they'll release a version and then they'll release the next version, which is real buggy. And so if you hard code it to a particular version, then you can continue working. And you can choose whatever, again, what versions. The source folder, in this case, I'm also showing you how to do Git, where you can, I'm sorry, the first slide, P, is how you can actually choose where the repo is. Because some companies will have their own internal pod files, and so they're not published anywhere else, they're just internally, so you can actually choose where your repo is, and that's what the first line does, and then you're choosing that thing. And then you can also choose, like Nathan showed earlier, where you want to pull if you need to pull a local version from your own GitHub repo because you made changes, like Nathan did. And then there's also Apple frameworks, which...
So frameworks are not CocoaPods, or are they CocoaPods?
You can put a framework into a CocoaPod, but most frameworks are not CocoaPods.
When we're saying framework, what do we mean? This is a folder, or it's a file? What is it?
It's actually a file-ish type thing. Apple's...
It's like a special...
It's a special file folder, basically.
Is this kind of like how Apple has your applications and applications, and they're actually .app
yes.
files, and inside the .app are package contents which contain all sorts of...
That is correct. That is what a framework...
That's kind of like a framework.
That is correct.
It looks like a folder, but
it's a specially designed...
It's a bundle of things.
Correct. So if you find that the thing that you get, like the SoundCloud, was it SoundCloud? You might find plugins out there that you want to integrate into your application that's not a CocoaPod, that the company just releases the framework file.
Spotify,
that's the one I was thinking.
Spotify published a framework, but didn't publish it on CocoaPods.
Yeah.
So they just said, hey, you can download our SDK, and it's just a .framework file.
Can you go back? You got to go back up a little bit. The frameworks, they're generated differently in actually, if you look at the Telerik UI, those are frameworks. They're not CocoaPods, and they integrate the framework into the NPM module, and so when it downloads, it's downloading the framework with it. The framework, if you run into frameworks, the way you have to integrate them is a little bit differently than a CocoaPod. Instead of using a pod file, you use a file called module.modulemap. And this module.modulemap file, which I think we're on the wrong folder. Oh, I guess so.
Now hold up a second, you're going pretty fast. So we got a framework. Where is the framework? Where do we put it?
The framework is actually in the same iOS folder. Everything that's iOS specific is inside that platform's iOS. So you would just drop your framework folder into that there, and then you'd also typically drop a module map into there.
Okay, the module map, does it go parallel to the framework?
Correct, most of the time. Now some frameworks have their module map, and so you don't have to do that. In this case, I'm showing you the Wikitude SDK, which is a framework. They have a module map already built in, so you don't have to do the work. But if they don't have one, then you put one out at the root directory of the iOS next to the framework. And this module map, actually, how you want to create it, is you give it your name of the module.module map. It's very critical, the name, just like the pod file. And you need to know what the header file is. And the header file is what you showed earlier. You have to go into the framework folder and then into the headers folder. And then once you go in the headers folder, you should see the .h. Typically they're with named umbrella, or they're just named the name of the framework. Like in the case of Spotify, it was spotify.h. And so you just find the master header file, and that's what you bring, and you copy that information into your module file. So this is what a module file looks like. It's framework module Spotify, so we named it Spotify. The umbrella header is going to be called Spotify H. You don't give it a path. You're just saying that this is what its header file's name. You're telling it you're wanting to export everything from the header file, And the module star export everything is another one of the ways to tell it to export everything. Most of the time the first export works, but I've run into a couple where the second one's needed. So it's safer just to do both lines.
That looks like some voodoo. In fact, my eyes are glazing over. What else you got?
And then the only other thing with
you got to get a new TV. There you go. All right.
Okay, on Android integration, there is called the Gradle file. When you are introducing third-party plugins for Android, because we've really covered CocoaPods and whatever, but on Android there's Gradle files. The Gradle files, there's 3 primary places you can find plugins like CocoaPods. I mean, it's really nice that CocoaPods is one. There's Android Arsenal, there's BinTray, JCenter, and there's Maven.org. All 3 of these are big places that you can find plugins for Android applications, native Android applications. And so in this case, you want to put it in the platform's Android folder and call include Gradle.
So I'm just going to look here. So Gradle, the Gradle file is for Android.
That is correct.
Okay, and Brad covered a bit of that. Metadata generation we kind of got into.
We did get into the TypeScript.
Some review there with the TypeScript typings. That's how we can get them in the metadata generator. This is the definition.
That is correct.
That we used. In the detailed version of the typings, there's kind of the detailed version, which is the JSON file that kind of goes along with that.
That is correct. There is a detailed mode that you can put in that gives you more metadata. It's really terse to read, but it does help you if you need to. And that bottom command line, if you need slides, will get you.
I'll tell you what, I've had enough of plugin talk. I'm actually really looking forward to getting back to our show, guys. So if you don't mind.
Thanks. Hey, I was thinking, I might watch a movie.
I am not programmed for friendship.
Now suit yourself.
That's enough television. All right?